Okay, so we're gonna start making the falling block traps that are going to be placed along this catwalk in room 3. So in order to do this, we're gonna make a new type of blueprint. So we've talked about blueprints a little bit. We've looked at our character blueprint. We've looked at our level blueprint, but now we're going to talk about creating a new blueprint class. Now, remember that a blueprint is essentially just a container that can hold lots of different types of assets and actors that will make a sort of a single interactable object within Unreal. So to create a new blueprint, what we're going to do is we're going to open up our content drawer. I'm going to dock it in the layout just so it stays there. And I think the first thing I'm going to do is to create a new folder here for our blueprints to stay organized. So let's right click and add a new folder, and let's just call this blueprints. Great. So let's go into our blueprints folder, and within this folder we are going to create a new blueprint class. So right click, and up at where it says create basic asset under the new folder, we're just going to select blueprint class. Now you'll get this pop-up window that's asking you to pick a parent class. Basically, what type of blueprint do you want to make? Is it just a regular actor, meaning any sort of generic type of thing that you can place in a level? Is it a pawn? Basically, can it receive input from a controller? Pawns include things like vehicles and characters. Down here we have character, which it says here is a type of pawn that includes the ability to walk around. This is the type of blueprint that our player character is. And then we have some more advanced things down here. We have a drop down which contains all classes for making more advanced things, but all the common ones, as you can see, are right here. So we are going to create a new actor blueprint, and all the descriptions are right here. An actor is an object that can be placed or spawned in the world. It is the most generic type of blueprint you can make. So let's click on actor. This will create our new blueprint class right here, and will give us the ability to name it. So I'm just going to name it BP for blueprint underscore falling block. Hit enter. Okay, so now we have our new blueprint class created. If we drag it into the world currently, we'll just get this sort of placeholder icon here that is basically just saying all we have right here is an empty blueprint. It's currently not doing anything. It doesn't have any static mesh components. It doesn't have any code in it, but we're going to change that. So if you have not already, double click to open it. And if it's the second time opening it, you may see a screen that looks like this. You read this note up here. It says, this is a data-only blueprint. So only default values are shown. It does not have any script or variables. So because we don't have any mesh, we don't have any code, it's just closing those windows for us because this blueprint is not utilizing any of that functionality. But we can get it back to the standard blueprint view if we just click Open Full Blueprint Editor. So now we have it back to our sort of default blueprint editor window. And if you compare this to the third person character, you'll see that this window is exactly the same. It has our components, it has our variables and functions, it has our event graphs, our viewport tab is here, and our details are right here. We just don't have any information in it yet. So the first thing we're going to add to it is our static mesh component. Now, remember, a static mesh is just any sort of physical object that you can see in-game in the world. So for our falling block, we need a static mesh for the block. So the way we're going to add a new component is just to come over into the Components tab and click Add. And I'm going to come down here to where it says Static Mesh. You can rename this if you like, or leave it static mesh. In our cases, it's not going to matter so much because we are only going to have one single static mesh component for this particular object. So I'm just going to press Enter to leave it. But if you have a blueprint with multiple types, multiple different static meshes, you may want to name them for clarity. Okay, so we've added our static mesh component, but we are not seeing any changes here in our viewport editor. That's because we have not told it what static mesh we want to add. We've only added basically a slot for the static mesh, but we haven't filled that slot with anything. So let's do that now. The way we're going to do that is we're going to select our static mesh in the component window here, and then we're going to look at the details panel over here. Again, if you have closed any of these windows or cannot find them, come up into window and open it through here. There's the details panel, my blueprint, components, all of your windows are available to reopen here in the window tab. So let's tell it we want sort of a block, like a cube, right, to represent the block. Again, we're going to replace these items later on when we get to art assets, but we need a placeholder mesh so that we can see and test it in the game. So we're going to come over here to the details panel, come down to the static mesh section, and under static mesh, you'll see this little icon, this little tab where it says none. Let's click on this drop down, and you can see all the mesh pieces that we have created, as well as the ones that were already in the game because of the template we chose. So I'm going to use a static mesh from the template, the third person template that we started with, which is called SM_cube. I'm going to select this one right here. So now if we zoom out in the viewport, we can see our cube right here. So currently, this is the only component in our blueprint. There's no code or anything, so functionally, it is the same as having a static mesh cube. Now, before I do anything else, I want to compile. I'm going to save it. I'm going to pull this tab out by clicking and dragging it and just dock it next to the level tab so I can quickly go back and forth. So because I already dragged my blueprint out into my scene, we can now see it updated here in the editor with our cube. Now, I'm looking at this and I'm thinking this cube is much too small. In fact, we need to compare it to the size of our player. So what I'm going to do is I'm just going to delete my player start up in room 1. I'm going to come back to room 2. And I'm going to add my player start back in so that when I hit play, I start right next to the cube. And I'm actually going to add, it's a little dark in here, I'm having trouble seeing, so I'm going to add a rect light by just clicking in the place actors, light, rect light. I'm just going to drag it in. I'm going to press E to pull up the rotator gizmo. I'm going to rotate it by 90 degrees to make it a ceiling light. I'm going to move it up to the ceiling, center it, open my details panel, and here where it says source width and source height, I'm just going to adjust these values to scale this light emitting plane to approximately the size of my ceiling. Okay, so now when I hit play, it's still kind of dark, so I'm going to also increase the intensity. I'm just going to slide this up until it's a little bit brighter. I could also, move this one over, or I could simply increase the intensity. It's at its default of 8 candelas, which I believe is a unit that indicates it's the light equivalent of 8 candles. So it's pretty dark. Again, I'm getting these. I'm just going to do a temporary fix on these by changing that one to movable. Okay, so now when we play, it's slightly easier to see. Okay, so this block is much too small. I need to about double its size. So the way I'm going to do this, instead of scaling it in the editor, although you can definitely scale it in the editor to get it to be the right size, and this is great for, if you just need to eyeball how big it is, that's an option. But the problem with this is that now if I want to drag out another falling block blueprint from the content browser, well, it's still going to be its original size because I have only changed the size of this particular instance. I have not changed the size of the default in the blueprint. And this concept should be somewhat familiar when we were talking about creating these static meshes and changing the default scales. So we want to change the default scale of this static mesh component of this blueprint. So what we're gonna do, first what I'm gonna do is I'm gonna click on this one, open the details panel, and I'm just gonna reset the scale just so it snaps back to its original default size. So I want to change the default, so I'm going to go back into the BP falling block blueprint editor. Again, if you have it open, just tab over or just double click. And I know that I want to about double the size. So I'm going to select the static mesh in the component hierarchy, and here where it says scale, I want to change all of these values to 2. So you can do this manually by typing in 2, 2, and 2, or if you want to lock the ratio of the scale, you can hit this lock button. And then when you type in 2, it will change all of those values to 2 because it's keeping the same relative uniform scale, I should say. Okay, let's hit compile and save. And now when we look at our editor, we see that it has updated here. And now if I drag out another one, you can see it is the appropriate size. So that's how we change the default. You may be thinking to yourself, well, this is quite powerful, because not only can we change the default, but we can change the instance. So if we needed to have falling blocks that did the same thing but were different sizes, for instance, well, we can do that very easily by dragging them out and making them different sizes. So blueprinting and instancing is a really powerful tool that's gonna, that will speed up your workflow a lot. But anyway, we want all our blocks to be the same size. So let's go back into this. And now what we need to do is, well, I want to raise this up, right? Because it needs to fall on the player. So you may be thinking, okay, well, we'll just raise it up in the editor. And this is a totally fine method to do, but I'm actually going to do it a slightly different way, because it's going to also require some more functionality here in order to detect when the player is running underneath it. Because remember, we only want these to fall when the player goes underneath it. So if we think back to our kill Z volume, basically what that was a box that, just did not have any visibility, that functioned such that when the player intersected with it, it did whatever we told it to do. So we're going to use that same basic principle here to create a trigger volume for this falling block trap. So we need to add a volume that is not the cube itself for the player to run through to trigger the falling of the cube. So instead of moving this up in the level editor, what I'm actually going to do is place it, align it with the ground where I want it, and I'm going to move this up in the blueprint editor itself. And I'm going to move it up by, I think, about 3 meters. Let's go 1, 2, 3. You'll see that we have the same grid snapping options we have here as we had in the level editor, so it works the same way. I just increased my grid size to 100 and moved it up 3 times. So because this is contained in a blueprint and is not just a static mesh, it considers the origin, the pivot point, the root, whatever you want to call it, as this icon right here, which is denoted by this default scene root in the components hierarchy. So now if I move this around relative to this point, when I compile and save, you can see that although I have not moved it off of this catwalk in the level editor, the block itself has moved up. Well, this is perfect. This is just what we want, because we want to be able to place these blocks along the catwalk and have the mesh part be hovering above. So now we need to add the volume itself for our player to run into. So let's return to our blueprint editor. Let's come into the components window, and we're going to add what is called a box collision. So under the add, we can just start searching box, and we're going to add a box collision. Now, box collisions are volumes that will not be rendered in game, but can still trigger events when another actor comes inside the bounds of this volume. So let's change the bounds of this volume to more appropriately match our mesh here. And the other thing I'm going to do really quickly before I do that, we can see that the pivot of this static mesh cube is in the corner, so that it's shifted sort of forward relative to our root. So I'm just going to come into the left view in this case. I'm just going to snap it over so it's centered above this. And I'm going to come into the top and do the same thing. So basically, I want this X to be over the origin. Okay, so now what we're going to do is we're going to snap the, we're going to scale the box to match our needs for this blueprint. So let's come back into left view, and we're going to move the box here. I'm going to press R to go into the scale tool. I'm just going to scale this so it's the same width here as our static mesh. And I'm going to scale it in the Z. And I'm actually going to turn my snapping back down to about 10 because I'm getting too wide of increments. So I'm going to scale it to something about like this. So it needs to be the same width as the box, and it needs to span the height from the bottom of our static mesh to the floor, which is going to be represented by right here. So if we go back into perspective, we can see that we're not fully scaled correctly. So let's go back into the top view. We're going to move this center of this box collision into the center of our blueprint. Go back into the scale tool by pressing R or selecting it up here. And we're going to scale along the Y until it matches the width of the box in the Y direction as well. So there we go. So let's look at it again in perspective. So this is what our blueprint now looks like. Because this box collision, I should say, is not going to be rendered in game, it is okay in this instance that we have a little bit of overlap, but if it bothers you, you can, continue to scale it until it is perfect. I think you just probably want to, no. Control Z to undo that. So you can scale it until it perfectly matches, but in this case, if it overlaps a little bit on the top or a little bit on the bottom, that's okay. Again, this is called a box collision, but it's not actually going to collide with anything as we have it set up. We're going to be able to run through it, but basically all it's going to do is inform the engine, the system, when we run through it to do something. So in our level editor now, in the editor view, we can now see our trigger volume underneath our static mesh, and this all moves together as a single object because it is contained within a single blueprint. However, if we press play and run through it right now, well, nothing is going to happen because we haven't told it to do anything yet. So let's get this functionality working. And just like we did with our bottomless pit, our pitfall, we need to know when the player is running through this box collision volume. So in order to do that, the first thing that we need to do is this blueprint, this BP falling block blueprint, needs to know who the player is. So we're going to do this the exact same way we did with our kill Z volume. We're going to, off of our event begin play, we're going to get our player character. Again, we have our player index of 0, and we have a return value of a character object reference. So from here, we're going to drag out, and we're going to type in cast to third person character. And some people, if you've watched other tutorials, they may cast to the third person character on this collision. This is a personal preference. I think this is a little bit cleaner because this operation right here contained in this node can be somewhat expensive performance-wise if you do it a lot. So because we're never changing our player character, I find it more efficient to cast it once at the beginning of play, save that reference as a variable. I think it's just a little bit cleaner. So same as we did with our kill Z, I'm going to right click here and I'm going to hit promote to variable and name it player ref. And you'll see down here in our variables tab, this looks just like it did in the level blueprint, except we have an additional drop down within our variables tab for the components contained here in the component hierarchy. So instead of pulling in references from our level itself, we can only really pull in references that are contained within this blueprint, because by default, each blueprint is only aware of itself. And that's sort of an abstract thing to say, but our level blueprint by default is sort of aware of everything that we place within the level, but a blueprint actor class is a self-contained sort of file folder, if you want to think of it that way, and it only knows about things within its own file. And if we want to tell it about anything outside of its file, such as the player character, well, we need to do something like cast it to the third-person character and set that as a variable. Okay, so we have created our player reference. And I'm just gonna group those and move it aside. So now what we need to do is something very similar to what we did with the kill Z, which we need to detect when this, our player, is colliding or overlapping with this box. So to do this, we can click on the box here, and if we right click, we'll get the same add events collision. You can add it here, or another way to do this, and this was the exact same result, it's just a different way to do it, is if you select any component here in the components hierarchy and you scroll all the way down on the details panel, you'll see a tab called events, and this will list all the events that are available for this type of component. So we have, all sorts of things here, but the second one here is on component begin overlap. So let's click the plus button here, and that will add this node automatically to our graph. And you'll see here we have a lot more options for the types of things we can do with this, because by default, a box collision is just a bit more versatile than a kill Z volume. Now, a kill Z volume is simply a specific type of box collision that specifically is made to kill the player when it interacts with it. So to use a box collision, sort of a generic version of a box collision, you're just going to have to give it a little bit more information on what you want it to do. So the first step is going to be exactly the same though. We're just going to get our player reference, we're going to compare it to the other actor, meaning whatever actor is overlapping with this box, by doing equals equals. We're going to connect these, and we're going to evaluate if this statement is true or false. Now, if it's false, meaning that whatever is overlapping with this box is not the player, well, we don't really want to do anything. But if it's true, we want to do something. So once again, let's just double check that this system, this trigger function, is working and evaluating this if statement the way we think it should. And we're going to do that by adding a print string. Let's connect this to make our information a little bit more specific. Compile and save. So now when we run through this trigger, it should print true up in the top left-hand corner of the screen. And it does. Great. So now we get into the more complicated bits. We have our trigger working, but now we need to tell it what to do when the player runs through this trigger. So we have to think about logically what needs to happen. We want to move this box from where it is down to the bottom here of the floor, the bottom of the blueprint, which is aligned with the floor. And the way that we're going to do that is, just checking my notes here, we're going to do this with what is called a timeline. And a timeline node in Unreal Engine is basically a way to do simple object animations. So we don't really want any sort of complex physics simulation, because one, this block would probably hit this catwalk and it would go flying off into space because it would bounce, right? Plus, physics simulations are just a little bit too complex for what we need this functionality to be. So we're going to do this with an object animation. So to do an object animation, we're going to use a timeline, as I said. So to get a timeline node, we're just going to go back into our BP falling block, our event graph. We're going to right click. We're going to search timeline. And we're going to get this search result at the bottom that says add timeline. So go ahead and click that. We can name our timeline. Let's call it block fall, something of that nature. And then we need to basically open this up now and give it values to tell the blueprint what sort of animation and what values we need to do. So let's first just connect true to play. And now to fill out this timeline with information, we're going to just double click it. Now that's going to open a new tab up here within your blueprint itself. And right now this tab is completely empty because we haven't added any information into it. So what we're going to do is we're going to hit this plus track button and we're going to add a float track. Now, if you're unfamiliar, a float is simply a number value that can contain a decimal, so not a whole number. So like 1.2 is a floating point value. So basically, this is just going to work like a graph, like an XY graph, that you may be familiar with from grade school. And we're going to give this graph a name first. We're going to call it, not new track, we're going to call it, right click, Z height, to describe what this graph is doing. Now, by default in the timeline, the x-axis here is going to be the value of time, and the y-axis here is going to be your variable value. So to add points to this graph, all we have to do is right-click on it, add key to float curve _0, and now we have a point on our graph. And if we click on this point, it will be highlighted in blue. If we click off of it, it will not. But if we click on it, it will be highlighted in blue here, and we will get sort of the x, y coordinate values up here. The x, of course, being time, and the y being the value. So we want this graph to start at a time of 0. Easy enough. So let's type in 0 here, and that will snap this point over here. So the value here is going to be a little bit trickier. We basically have to understand what we're describing with this graph. So what we want to happen is we want the graph to represent the fall that the block is going to make. So we need to know the height of the block at our starting point. So we want to look at the Z location of our static mesh here. Again, we don't want to move the entire blueprint because that would move the collision volume with it, and then our blueprint would no longer work because the collision volume would be in a different place and our character would no longer be able to run through it. We only want to move this static mesh component. And in fact, at the moment, if we move this static mesh, because of the way that these were added, the box is going to move with it, because you'll see that this box is sort of indented from this static mesh, meaning that the static mesh is a parent of the box. So let's decouple that, and the way we're going to do that is we're going to select the box, and we're going to drop it back onto the static mesh, and you'll get this little pop-up that says drop here to detach the box from the static mesh, and that's what we want. So we want them detached so that we can move this box independently of this trigger volume. Okay. Okay, so I had to check my notes here, but actually what we're going to do is this static mesh needs to have a location of 0, and this box does need to be parented, I believe, and we just need to adjust the heights here. Again, there's multiple ways to accomplish most of these things. So if you have a different idea for how you want to accomplish it, by all means, try it out. But I was just referencing my notes, and I realized that the way that I built this the first time through was slightly different. So all I've done here is I've just moved things around. So I've matched the pivot point of this static mesh object to the default scene root. So basically when we come in here to our level editor, we see that it's now on the ground, but we're just going to move it, physically move the entire thing up so that this box collision is going to extend down beyond sort of the origin, which is where our little move gizmo appears. And the reason I did this is because I needed this value here to be able to make the block fall the way that I had originally planned to make it fall. So all I'm going to do here, I'm actually going to raise this block up because I want it to be sort of above this ceiling height. I'm going to raise it to a height of 410 centimeters, so it's right there. And I just need to extend this, the height of this, excuse me, the height of this box collision down a little bit. So I'm just going to select it in the blueprint editor, and I'm going to move it slightly down. And I'm just going to scale it a little bit. I'm actually going to reset the scale to 1 and do it this way just so that we maintain a scale of 1 here so we don't get confused. 50, 50, and I believe 100 should work. Yeah, that looks like it'll work. Okay. So my apologies for the confusion. This should be the rough setup of your box. We have a static mesh parented to our default scene root. So that will give it a relative location of 0, 0, 0, a scale of 2. We have the box underneath it. Again, I do not believe this needs to be parented, but the way I had it set up originally it was. So in the interest of staying close to my notes, I'm going to keep it the same. It has a location of 50, 50, negative 100, and a box extent of 50, 50, 100, and that just affects the size of this collision. Compile, save it, and when we look at this in our level editor, it looks like this. So we have the gizmo up here at the bottom of the box. Okay, so my apologies for the quick diversion. Let's return to our event graph. And let's double click to return to our block fall timeline. So we know we want it to start at a time of 0, and I want it to start, the value is going to be the height in the Z direction, which is this blue one here. The height in the world at the Z direction. I basically want this timeline to start where it is placed currently. So in order to get that information, I'm going to open up the details panel, and I'm just going to look at the height here. And again, I placed it at about 410 centimeters in the Z, which is denoted by the blue value in the location. So what I'm going to do here is when I select this curve on my timeline float track, I'm just going to change the value to 410. Now, you won't be able to see it anymore because it's placed this, way off of the viewport. So I'm just going to hit zoom to fit horizontal and zoom to fit vertical. And we can use the mouse wheel to scroll out a little bit. Whoops. Accidentally moved it. We can use the mouse wheel to scroll in and out of our timeline. And we can hold right click and drag to pan around in our timeline. But basically we have our first point here in the curve. Okay, so now if we played this right now, nothing would happen because our curve is a straight line. So we need to add a second value at a second time signature in order for an animation to happen. So in order to do that, I'm just going to right click on the curve and I'm going to press add key to curve float 0. So this adds a second point here, and you can see it's highlighted in blue when I click on it. So I want this block to fall relatively fast. Now the time values here are all in seconds. So if I gave this a value of 1, it would be at 1 second, it would finish this animation essentially. I actually want it to be much quicker than that. I want it to be at about 0.25, so a quarter of a second. It's going to fall very rapidly. And I want the value, the second value here, to be a height of 0. Now, the last thing we really need to do here is we need to change the length of this animation, because currently if we scroll all the way out, we'll see our 2 points, you know, correspond right here, and then there's just a lot of like dead space in our timeline. That is because the length of our timeline is currently set to 5 seconds by default. So let's change the length of our timeline to fit the points on our curve. So all I'm going to do is come up here to where it says length 5. I'm going to change that to 0.25 to represent the length of our actual animation. Okay. So let's compile and save that. And if we play it right now, if we play it without falling, nothing happens. So we're going to take a quick break, and we're going to come back and address why nothing is currently happening.